Giuseppe Giorgi. It's okay, the pronunciation? Okay. He's going to present us from just ideas to wet demonstrations, the experience of MOREnergy Lab. They are from MOREnergy Lab, Politecnico di Torino, Italy, and the stage is all yours.
Thank you. So I think I'll try to stand here, over there. Let's see if it works also over there. Okay. Yes, so today's presentation is about an helicopter view on the research group I'm part of. So Politecnico di Torino is a university, which is an engineering school in Turin. And the MOREnergy Lab, as we mentioned yesterday, is a research group of marine offshore renewable energy lab. So as you can guess, we do marine offshore renewable energy. So I want to share briefly in the 15 minutes we have, 20. I try to be 15, although I prepare for 20. Very briefly what we did in the last 15 years, just to share our experience with you. Since in Argentina you want to start a lot of effort, you want to face plenty of challenges in wave energy to do something here as well, we may just share our own experience. So, if you don't know, Turin is in the north of Italy, close to France, and our research group is made of, the updated figures is about 24 PhD students, 2 professors and 6 postdocs, so the group grew quite larger. This is already from 2 years ago, so we are even larger than this, and as you may guess also from yesterday, we like to have fun together. So in wave energy, usually people are chill and like to be together, so that's the very first message I want to give. If you want to embrace the path of wave energy, also try to be chill and be relaxed. So in the group, we cover plenty of different areas of expertise because we have been developing our own wave energy device. Well, 3 of them. So since we did all by ourselves, we needed to develop every little piece that you need to develop for getting to the water. So we do that in wave energy, also floating offshore wind. We do multi-objective energy platforms. I'm going to cover that in a little bit. So we need to understand very well the resource. We need to assess the resource with models and data. We do the mooring design, experimental campaign, a lot of control strategy, optimization, computational fluid dynamics. So all the different little pieces that you can imagine about developing a energy converter, we had to understand how that works. So we started from 0, and slowly we got to some level of expertise. So wave energy is complex. There are, as also John mentioned yesterday, there are plenty of different concepts, working principles, and very different from each from the other one. And I'm putting these GIFs here not because I want to explain them, just because you may have been using this 2008 GIF, which I think is horrible. So we did some updated version. They're for free. They're available on our website, so just go there and use them. There's all of these different concepts and also some other ones, so you can download them and use them. I think they're better, but it's your choice. So coming to the device that we have been developing, in wave energy we developed 2 inertial wave energy converters, where the main advantage is that there's no moving part in water. So since the coupling between the waves and the hull is made through the inertial body, so heavy objects inside the hull, everything that is moving is inside, sealed, with no moving part in water, which is very good for maintenance and reliability. So our 2 devices are the inertial wave energy converter, which hosts a gyroscope, so we exploit the gyroscopic effect. And similarly, we developed the PeWEC, is the pendulum wave energy converter, which performs the coupling with the pendulum mass. So we developed both of them. Starting from ISWEC, which was the first one that really kickstarted our activities in wave energy. We started back in 2006 or 7 with the ideas and the patent. We patented pretty early. And then we went to the whole process for development, taking small steps, as they should be, from very small scale, 1 to 45, up to larger wave tank tests. And in 2015, we managed, all alone with the effort of the group alone, to install the first full-scale device in Pantelleria Island, which is in the south of Italy. And that was a kind of a turning point that was able to attract the interest of investors. And then we went back to Pantelleria with another full-scale device in 2023, actually, in February. A similar path was followed for the PeWEC device, staying within a research institution as the partner, which is a pendulum wave energy device. But again, we went from first numerical modeling, then rough wave-time testing, and then slowly increasing the complexity. And this was a test in Naples in 2021, where we did the extreme test for the mooring system. So I want to highlight a little bit better the Pantelleria case, because it was really a success story. It's not that common to be able to install something in the water. It's also complex to install a wave buoy. Installing this guy, it's complex from the permitting process, as Claudio will mention in the next one. But all the modeling and the construction, the procurement, and the plenty of costs all increase several folds with respect to what you could imagine in the beginning. So we installed it here in the Pantelleria Island. This is a picture of myself from a couple of months ago. So just to share that we actually do ourselves everything. So not just staying in the lab, but all the experimental tests up to the offshore campaign. And this was a storm that we withstood pretty well, I would say. And this really leads me to share our own views on how we want to have our research lab. So we don't want to just stay in front of our desk. And we do as much as we can in Turin, but you know, in Turin there's no sea. So we do all the numerical modeling, but also we do plenty of dry tests, which are very important in wave energy because you need to decrease the complexity of the wave structure interaction, which are very difficult to model in an accurate way. So we do plenty of dry tests, but then we move to large wave tanks for the experiments. And finally, in Pantelleria, we have our own consented area for research purposes, which is available. So we installed there our device. So this is the idea of a diffused laboratory. These are just some quick views on the wave tanks. So these are just some examples, but we've really been traveling around Europe with our own funds or with some European funds. So it's very important to do experiments. That's just the message. And we did plenty of them. And from each one of them, we learned precious lessons that cannot be learned in the lab again. We also developed this WEPA concept, which is a point absorber, so not just inertial devices, but also point absorbers, which is both producing energy and electricity and clean water. So there is a desalination plant inside, and there is a hybrid combination of wave energy, but also wind and solar panels. So there's plenty of hype about hybrid system, but really no one has installed anything. So we decided to do it with very limited budget in limited time. So it was a 3 years project from the idea to the installation. So we did the modeling and the optimization, and we finally got to construction and installation. This is in Sardinia, in the west coast of Sardinia. And this was installed last May or June. And it's working. It's kind of working. So we did all the challenges that comes with the installation, but it is working. It is there. For doing all of this, we perform also the resource assessment. And I heard from Damien that you want to do the same in Mar del Plata, so I thought about including this slide as well. So these are 3 measurement devices that we have, and a DCP on the seabed, wave rider from DataWell, and a wave buoy from San Diego. And again, these are pictures that I took personally from Pantelleria, so we go there and install it. And the permitting process also here is not straightforward, but we do it. But we also do numerical modeling, so with downscaling approaches, like SWAN or WaveWatch 3, to get the higher resolution in space from the available dataset open access. And also we do georeferenced analysis of the available area. We include all the buffer zone, permitting zones, traffic density in order to select the best installation site. So we combine all of these information to, for example, in here in the middle, I put the statistical representation of wave and potentially wind, which really can lead the designer both for the design of the machine, also the location where you want to install it. And then, I'm not going into this slide, but we do all of the rest that we need to do for controlling the device. So we develop plenty of control, both model-based and data-driven, also with robust approaches. We use holistic optimization, including techno-economic considerations. So we include all the cost assessment within the optimization of the device, so you don't have to just optimize the productivity, but really think about the costs, which are very, very important in wave energy. And we do that, since it's a very complex problem, we do that with genetic algorithms to get to the optimal device, at least a Pareto front of optimal devices. We do plenty of numerical models, also CFD, but also nonlinear potential flow. And we also develop some open access tools. You can see here on the left MOST, which is a Simulink-based open access simulation tool for floating offshore wind. And recently it's been coupled with the WECSIM. So from the wave energy community, we know WECSIM from NREL. With a collaboration with them, we decided to include MOST within WECSIM, which may be very important for also hybrid platforms and for floating offshore wind by itself. And this is the spatial analysis tool that I showed before, is also open access. And we have all the European seas included. First of all, you can have an easy access to the resource in every cell in European seas. We didn't do it for the whole world just because of database restrictions and costs. But this is open access. You can access all the resource and also the productivity of some devices and do some preliminary analysis about the cost of energy, for example. So this was all the academic development part. I just want to share also some hints about the infrastructures. So I mentioned we do hardware in the loop tests. So we have a hydraulic PTO hardware in the loop, where we simulated the power takeoff of the half-scale device we installed in the Adriatic Sea. We have a back-to-back electric PTO as well, so for testing PTO, for example, for offshore wind, also onshore wind, and wave energy. And recently, the last test we did was for the spring of the point absorber concept that I showed before. And we recently installed this Stewart platform, arrived family 2 months ago. And this is a 6 degrees of freedom Stewart platform, can move up to 1,500 kilograms and 1 G of acceleration. Here we're going to test, let's see if this moves. No, yeah. So we're going to test, for example, gyroscope moving around in all 6 degrees of freedom, so complex dynamics systems. And if you're lucky enough, we are going to build our own wave tank as well. This is planned for the next 2 to 3 years, which is a mid-size wave tank with current and wind, so the most comprehensive wave tank we can, since we want to make an efficient use of the budget here. So that's the plan, so we don't need to move around anymore, or as much. And finally, we are also involved in the Clean Energy for EU Islands Secretariat, which is a European Union initiative where we are the representative for Italy, where we lead and advise small communities of islands to reach their decarbonization targets. So we analyze the energy system of the island, and we produce an action plan every 5 years up to 2050, so that can actually get to the net zero energy production. And we do that in a process including all the stakeholders of the island, so there is a direct involvement of everyone, because the energy transition is not something that should be top-down, but should be a collaborative effort. So, and we do that from the very first moment, and I think that is very important. If you want to introduce something new in a community, you should involve the community at the very first stage. And we did that in a pretty successful way. And finally, and I'm going closing here, because probably I'm long, but we also do technology transfer. So we believe we shouldn't be restraining ourselves in the lab for just research. but we also do technology transfer because there are plenty of stakeholders also from the innovation side, and we do talk with them. So the first spin-off was made 12 years ago, was WEPA Energy, which was really facilitating the engineering and constructions of the device, because purchase is not easy for university. So we created our spin-off to have the two sides in just one. And then recently we started again. So we founded MASPAC 1 year ago. MASPAC, I'm a co-founder and CTO of this one, is using Earth observation satellite data for doing better metocean surveys using artificial intelligence. Because satellites, they do measure wave and wind quantities when they go around the Earth, but they revisit time. So when the satellite goes back in the same spot where you want the data, is probably 1, 2, 3 days, because there are not so many satellites. So this is good for climate monitoring, but it's not good enough for offshore engineering, because we want wave data every 3 hours. So to cope with that, we use artificial intelligence in a way to combine plenty of different satellites and get a higher resolution in space and time. And so this is the startup, is up and running. And the next one will be in probably March next year, will be funded, is Seaform, where we are going to build very large floating platforms for living purposes. And so they are going to be modular, and so the idea and the vision is to take the life on water. So we're going to develop all the different modular technologies that can enable actual life in the water. So this is a longer range vision. And finally, also, we think about waterborne mobility, so with electric boats, mostly for taxi uses. And these are for the decarbonization of transportation in water, especially thinking in small distances, so not very large boats. And we're going to electrify them, but also including hydrogen-based mobility. So, very last thing, we are here, so we have an international attitude. So I want to say that we are very much looking for collaborating, and we send our PhDs around Europe and also the world always. Among the 3 years they have to do their PhD, at least 1 year or 6 months they are abroad. And some of the people here have hosted already. And so if you want to collaborate with us, we can send our PhD over, and we can also host during your PhD. And also, as postdoctoral positions, they are available. We are hiring currently because we won a couple of European projects. So if you want to do a postdoc, you can just contact us. And also, there are the Marie Curie Action that are very prestigious fellowships. So we won already a couple of them. So they are difficult to write, but we wrote them and we won. So I was the first one, and then also Nicolas won another one after me. So you can apply with us, we can help, and hopefully we can win that. And Argentina has plenty of countries from South America that are eligible for funding for Horizon Europe projects. So if you have some project in mind that can fall within the scope of Horizon Europe calls, we can also collaborate in collaborative project. And anything you do also in South America, if you want technical advice or if there is any framework where we could be integrated, we would be happy to be here and work together. So, thank you.
Well, many thanks. Anyone has questions?
First of all, very good presentation. It's very interesting. My question is regarding the transport of energy from the device that is inertial. How do you transport the energy from the sea to the earth?
Yeah, the installation site for the two systems we installed. So one is the ISWEC, the other one is WEPA. It's about 500 meters from shore, so it's not very far away. So we have an export dynamic cable that goes from the device, go on the seabed, and then we take it to shore, and then we connect it to the grid, talking with the local DSO. So we have an agreement with the DSO, so we can connect the cable to the electric cabin on shore.
Another question? I have one. Now, you mentioned this ISWEC device.
Yeah.
You know how it compares the conversion efficiency with the standard devices, like with external moving parts?
Well, I just can put it there. Let's put this one.
Interesting topology.
Not to be egocentric. Yeah, so the conversion efficiency. So the objective of an energy converter is to deliver cheap energy. So I would say the question should be kind of encompassing all the efficiency and the costs altogether. So the efficiency is relatively good. Is not one of the highest efficiency overall, but the very advantage of this device is that it's all sealed. So the operational costs and maintenance costs are very low. So if you balance a good efficiency with a very, very low maintenance cost, then the overall levelized cost of energy will drop.
Many thanks. And you also mentioned this steward platform. You know, I am from the control field side. So when is this going to be ready to conduct control tests and so on?
It's ready. We finished all the installation and the checks on the machine in September. So right now there is a PhD student who's doing his own test there with a U-tank. There was a U-tank somewhere here. Well, we have a U-tank, which is a tuning platform. Where did I see it? Well, it doesn't matter. So we are going to test a U-tank, which is a device that is usually used for stabilizing big ships, but we use it for tuning to ocean wave periods, the wave energy devices. And we are already testing that on the Stewart machine.
Excellent. Thank you very much. Oops.
It's very complicated to, I mean, like, oof. To put the devices in the sea, I think you need some permits or something. How difficult or how expensive to achieve that?
For the permits and consenting, well, next presentation will be just about that. But it is difficult. We, as a research center, we managed to have a consented area for research purposes. So if you are a private or a company, then it's more complicated. Already for us was complicated, but we managed after talking with a lot of people, but yeah, he will talk about that. At the expensive part, yeah, it is expensive, and you need to plan it very well. All the installation procedures are complex. You know, you need the right vessels, you need the certification. So it's a long process, but it's all learned by doing. So it's very difficult to know everything by the first moment. So you try to do it, and then you hit wall, then you come back, you heal, and then you go back again. So it's an iterative process. That's why it took many years, but we got to a point where we understood more or less what we need to do.
Any more questions? Thank you very much, Giuseppe.